Okay. What's the integral of 1 over x? ln of x. And technically, you have to do the absolute value because you could have x that's not there. But I'm not going to make that huge of a deal out of it. If you forget the absolute value, I'm not going to mark it wrong.
Is there any place where you wouldn't put it there? Because I think my teacher from last whatever high school did like absolute value always.
Yeah, you can. It's because you can't take the natural log of a negative number. It has to be the absolute value there. The thing is it doesn't actually really change any of your calculations going through. So it's like it's just assumed you have to do the absolute value anyway. It's kind of like in the domain at that point. So I said it's one of those things. Like if you forget to put it, I'm not going to mark it wrong, but you have to assume it's there because you can't do the natural log of a negative number. All right. So what's the integral of 1 over x plus 2? It is ln of x plus 2. So when we do this one, we actually have to do, in essence, a u substitution. U is x plus 2. Du is just dx because it cancels itself out. So it ends up becoming the exact same thing as the integral of 1 over u, which is 1 over x plus 2. Good. All right. Well, yeah, let's see. The amount of things we're going to do today, this C is going to be the least of our worries at the end. All right. It will become a bigger issue next chapter because we actually have to do some solving. All right, so we got 2 over x minus 1 over x plus 2. So how would I do this integral? Yeah, so remember, integration, as long as it's addition and subtraction, I can split it up. So I can do the integral of 2 over x minus 1 minus the integral of 1 over x plus 2. So what's going to be the integral of 2 over x minus 1? Yeah, it's going to be natural log of x minus 1 with the 2 in front of it. It's 2 times it. And this one we already did. It's just the ln of x plus 2. Let's see. Congratulations. You can do division of or integration of division. Done. No, I'm just kidding. Anybody have trouble with that? We're good to there? Awesome. So how do we do this? No longer is it just a number over or a single factor, right? To do it. All right. So let's take a step back. How do I put those two fractions together? I need a common denominator, right? So my common denominator is going to be 8 times 7, correct? And would be 56. And then I'd multiply the 3 times the 7 and the 4 times the 8, correct? Okay. And then I would do that and put them together. So in this case, it'd be 56. 21 plus 32 is 53. think. All right. Everybody vaguely remember doing that back in probably middle school or even like 6th grade? All right. So let's look at that. Let's look at the problem we just did a second ago. What's it? 2 over. Minus 1 over x plus 2, if I remember right. Yes. All right. 2 or 1? Yep. 1. Okay, good. How would I put that together? Yeah, same concept, right? 2 x plus 2 minus 1 x minus 1 over x minus 1 x plus 2. So I got, if we do this quickly up here, 2x plus 4 minus x plus 1. And down here I'd have x squared minus 1x plus 2x minus 2. So if we put all that together, I've got x plus 5 over x squared plus x minus 2. Which is that. So that is the same thing as saying 1 over x minus 1 minus 1, or yeah, 1 over. So those are the exact same thing. The question is how do I go from here to here? Because going from this side, going the other way, going this way, it's easy. We can do that. That's where integration by parts comes into play. So our goal is really to figure out how to take, and actually the majority of this is going to be algebra, because we have to take that fraction and split it apart into pieces. Because then I can take basically the ln's of each one of them, and I'm done. All right. We can't do substitution.
No. Yeah. Back at bottom.
Yes. So yes, first step would be to factor the bottom. Yes. So we would, if we factored the bottom, we would get that part over there. That's definitely going to be very helpful. So yes. So let's actually do that. So we have x minus 1 and x plus 2, because I've already done that. And x plus 5 there. Huh? Two numbers. Well, if it's easy ones like this one, it's two numbers that multiply to c and add to b. Two numbers that multiply to -2 and add to 1. For the easy ones. The more complicated ones aren't that easy, but in general, that's going to be the fastest way to do the integration for the factor. All right. So now we need to, we have the x minus 1 here. And then plus x plus 2 here. So we need something up here. So we basically have x plus 5 equals a times x plus 2 plus b times x minus 1. Right? The top's got to equal basically that. Correct or no? Everybody got how I went to there? So it's basically, again, we're just going backwards. We split the bottom up. So we're going to take the bottom and we're going to make it into each of the factors. So in this case, I have two factors, the x minus 1 and the x plus 2. And I need something on the top that when I multiply to put them back together, they equal x plus 5. Okay? So I used to show this the hard way. The hard way always works. You can always do system of equations, and it will always work for this. All right. However, there's another way that pretty much always works, which we're gonna try. So when you're looking to solve this, if I can get rid of things, it makes my life easier. So if I set x equal to 1, and I'm going to plug 1 into this entire problem. Before anybody asks why I chose 1, you'll see why in a second if you don't already get it. So 1 plus 5 is 6. A, 1 plus 3 is, or 1 plus 2 is 3. B, 1 minus 1 is 0. That's why I chose the 1. Because I got rid of my B. So that's gone, which means A equals 2. Because I have 3A equals 6, divided by 3, so A equals 2. So what's another number I want to plug in and try? -2. So -2 plus 5 is 3. -2 plus 2 is 0. -2 minus 1 is -3. So in this case, that's gone. So B equals negative. So my answer would have been 2 over x minus 1 plus -1 over x plus 2, which is what I originally had to begin with. Okay. And then we can just do the integration of those, which we've already done. So I don't have to redo that one. And actually, believe it or not, that's integration by parts. The problems get a little more complicated, a little more steps in there, but that's in essence the actual entire theme of integration by parts. That's what you have to do. You're taking a single fraction and splitting it into parts to do the integration of each of those parts. And the goal is to get it to be some whole number or some number. It doesn't even have to be a whole number, just a constant over a linear term. If I have a constant over a linear term, I can just make it ln and I'd be done. Okay? All right, let's skip that one. And this is called actually case 1. So actually move this one over. All right, so let's do this one. So again, what's the first step in my process? I need to do what? I have to factor the bottom. Okay, so step 1, factor the bottom. So factor this bottom part out. I rewrite this problem wrong? Did I miss a number? I had to rewrite all these because they were in the, to do them in the black. I just want to make sure I didn't miss a number. Oh, it's not 2 in the middle, it's 3. That's the mistake. Knew something was wrong. Because actually, that one, that's as far as you can factor it.
Okay.
That's literally as far as you can go with that one. Okay. And we need to get it down into linear terms, which means no squares.
Okay,
So 2x squared plus 3x. Root 2x to the third plus 3x squared minus 2x. Minus 2x. Okay. So we're going to take out a x, and we're left with 2x squared plus 3x minus 2.
Plus 2x squared plus 3x squared.
2x to the third. There was an extra, because that's where we're pulling out the x. So this is going to become 2x minus 1, I think it was 2x minus 1. Yeah, and x plus 2. If you'd like to remember how to do this, we're looking for two numbers that multiply to -4 and add to 3, which would be -4 and 1. So I have 2x squared plus 4x minus 1x minus 2. I can pull out a 2x out of this side, and I'm left with x plus 1, or x plus 2. And I can pull out a -1 on that one, and I'm left with x plus 2. So I have 2x minus 1 and x plus 2. That's how you factor when there's not when there's a number in front, without having to guess and check, basically. All right. So we now have this to this. -4 and 3. You're multiplying -4 and adding 3, which is 4 and -1. So when you have a number in front, technically it's always there. You multiply a times c, which is 2 and -2. When there's no number in front, it's a 1, which just gives you c. That's why I don't have to worry about the a. So, but if there's a number there, you have to worry about it. The other way some people have taught it is literally it's basically trial and error. You're guessing and checking. You're looking for two numbers that multiply to 2, two numbers that multiply to -2, and you're looking at combinations of them that are going to add to the 3 in the middle. I've always liked the more procedural way to do it. Seems to work out a little bit better. All right, so we have this now that we can do our integration by parts on. So my 3 parts I'm going to have for this, I'm going to have a over x plus b over 2x minus 1 and c over x plus 2. So since I have 3 parts down the bottom, I'm going to have 3 fractions. So what am I going to multiply the A by? Nope. Which factors am I multiplying the A by? The two factors that are not under the A. So 2x minus 1 and x plus 2. The B is then x and x plus 2. And the C is x and 2x minus 1. So you're going to multiply each letter on top by the pieces that are not underneath it. And the one we did before, we only had 2. So it was literally we just did the cross basically. But since there's 3 of them, we have to multiply it by more parts. So the A is multiplied by these 2 because they're not under the A. The B is multiplied by the x of the x plus 2. And the C is multiplied by the x of the 2x plus 2. I've got this nice big long problem. But we're going to make it simpler. So what number do you want to make x equal?
0? Oh, no, no.
Yep, 0 works because I have the x. Negative 2 would work. Yep, negative 2. And the other one is going to be 1/2. Those are the 3 numbers that are going to make something in this problem 0. All right, so if we do 0, this side becomes just negative 1 equals A times negative 1 times 2. And the B and the C both cancel out. Any questions on how I got that? Because in all honesty, this is probably the hardest part of the problem. As long as you can factor. So we picked 0. So 0 is going to cancel out that term right there and that term right there. So that basically makes that whole thing 0 because we're multiplying. So the B and the C term both all cancel out. So that means it's 2A. The negative 1 equals negative 2A. So A equals 1/2. So now let's plug in negative 2 and see what we get. So if I plug in negative 2, I get 4 minus 4, negative 1 again. Equals, this side's going to cancel out because I'm canceling out that one. So the A is canceling out and the B is canceling out. So I'm left with the C. So negative 2 and negative 5. So C equals negative 1/10. Yes. I picked ones that are going to make zeros. So if we look at these, because in essence, these are the things that I have on the bottom, right? Those are the things I'm multiplying by. So if I plug in 0, that becomes 0, right? So that means this piece here is going to disappear because then it becomes 0 is 0. So that's gone and that's gone. If I pick -2, that becomes 0. Which means this becomes 0, so that whole part's gone. That whole part's gone, and all that. So the goal is to basically pick numbers that are going to help me.
Right.
And now if we do a half, so I have 1/4 plus 1 minus 1, so that's just 1/4. So now this side, the 1/2 is going to cancel out the A and the C. So I'm left with the B. So 1/2. And then that's going to be 5/2. So B equals 1/5. All right. So any questions how I got A, B, and C? All right. So step 1, factor it out, break up my linear terms. Step 2, find me my coefficients that are going to be on top. Step 3, find my integral. So now we have A was 1/2 over X. Do not put the thing on the bottom. Just leave it on top. We'll see why in a second. 1/5, 2x minus 1, and -1/10, x plus 2. Remember when we had a 2 on the top? It literally was just in front of the ln. That's why don't put the thing down the bottom, because those numbers are just going to be in front of my ln. So it just saves you one less thing that you have to think about when you're doing your ln's. So this first one is going to be 1/2 ln of x. The second one's going to be 1/5. But what about this 2x minus 1 down here?
For LN, it's like X
Almost. Right. I got that 2. So if I make this, because remember, we're doing u substitution. So if I make this u equals 2x minus 1, du is 2 dx. So I have a half that I have to pull out. So I still have a half that I have to pull out. And then it's my ln of 2x minus 1. I'll agree to write that down before I erase it.
So could you just simplify that as 1 over time.
Yeah, I'm gonna do that in the next step. I just didn't because I didn't want people to go, where would the 1/5 go? So I wrote it twice there. So I'm gonna rewrite the problem in a second on the bottom. All right. And now the last one is minus 1/10 ln of x plus 2. So I have 1/2 ln of x plus 1/10 ln of 2x minus 1 minus 1/10 ln of x plus 2. So when we're doing linear terms like this, the only thing you actually have to think about is if there's a number in front of x. If there's something in front of that x, I have to do it as 1 over whatever's there. So like there was a 2 in front of the x, so I pulled out a half, in essence. Questions? Is it as bad as everybody thought?
Well, I just got lost.
Where'd you get lost?
Where does the 1/2 come
The 2 in front. That was that U
That's it.
substitution.
from? It just comes.
Yeah, so basically, because remember, U is the 2x minus 1, so du is 2
Oh, yeah.
dx. So you have to plot the 2. That's where that 1/2 came from. Is that 2 right there. Honestly, this one's not hard. It's just a lot of little places you can make a little mistake. So it's like, I actually think the trig substitution that we did on Tuesday is harder, but
It's shorter.
it's shorter. It's less little places. It's actually less algebra. Like this is all stuff that you've all seen, but long time ago. Like before pre-calc for most, when you actually learn most of the stuff with factoring and dealing with fractions and stuff like that. So it's like, it's a lot of old stuff that you have to then remember how to do. And I'm going to add one more thing on that too, that you're going to have to remember how to do, because you're going to have to remember how to do long division.
No, so it's a polynomial.
Yep.
No.
Yep. That wonderful thing too. So yeah, we have to do long division next. Yes, that's why I said that's why I think makes this section harder than the other ones. It's a lot of old stuff that you have to remember how to do. And the one thing that I actually removed that always works is systems of equations, which you also have to do this stuff. But that's where instead of doing systems of equations, we're picking numbers to do it. So I eliminated having to reteach you how to do systems of equations. So yeah. All right, let's look at this one. So, and the other problems that we've done, so in this problem that we did, if you notice the exponent at the bottom is bigger than the top. Okay. If the exponent on the bottom is bigger than the top, you're good. You can just start doing the integration by parts, no problem. If it is equal to the top or less than the top, you have to do long division. So let's do a problem with long division. And unfortunately, I would say, okay, you could do synthetic division, which is a lot easier and a lot shorter to deal with, but that only works when it's a linear equation, a linear term, not if it's a quadratic, and those things do come up to play a lot more often than a linear term does. So we actually have to do out long division. Okay, so let's go back to, I'm not going to go back to the elementary school long division, which I usually do, and do the actual numbers, but because I want to actually do some other problems. but it's in essence the same thing. So we're going to look at, so we have x minus 1. My divisor is on the outside. Then I have my house. When you write your house and you write your thing inside your house, make sure you have all your terms. Yes. Don't lose the x squared. So I have 0x squared plus x plus 0. You might not need it. Okay? You might not need it.
What did you do?
So it was x to the third plus x. I'm missing an x squared term. So I put a 0x squared in there because I want that placeholder in case I need that space, in case I'm going to come up with that an x squared. All right. So it's just a great habit to get into, to have every term in your division so you don't mess up where you're putting things. Okay. All right. How many times does x go into x to the third? So I have x squared. Or the other way to think about it is, what do I have to multiply x by to get x to the third? X squared. So now I multiply x squared times x is x to the third. X squared times negative 1 is negative x squared. Okay? What's the next step? Now you know why I put those placeholders in there. Because if I didn't have an x squared, you're going to try to jam x squared in between the two things, and you're going to screw something up. We got to subtract them. If you've done this right, the first two terms should cancel. The first things should cancel out. If you didn't, they won't cancel out and you did something wrong. So so I have x squared and then bring everything else down. X goes into x squared once. So that's an x. I multiply. It was. And then I changed, because I'm subtracting, so you change its signs. Change my signs. So I have 2x plus 0. And then I have plus 2. So 2x minus 2. Change my signs. And I have a remainder of 2. So this problem becomes x squared plus x plus 2 plus 2 over x minus 1. And now everybody's got to migrate.
That makes sense.
Like I said, it's a different kind of hard. I think they're both hard in their own ways. This is a different kind of hard. I don't think the math is hard. I think the math was harder with dealing with the trig functions and the square roots and the triangles and angles and all that other stuff. I think the math was harder then. This is harder because it's all stuff everyone in here knew at some point, but you haven't used it in God knows how long. Like, I'd be willing to bet this is the first time any of you have seen long division in probably since sophomore year of high school, maybe junior, depending on what school you went to. All right, so it's been a while. So for some of you, it could be decades. So that's what I'm saying. It's like, it's not hard in terms of math. It's hard in terms of trying to remember all the algebra. So, and unfortunately, that's what happens when we have to deal with the fractions. It's like we have to do all these other things to get the fractions going. Okay. The nice thing is with this problem, we're actually done. We just have to do the integral for it, which it's already set up to be able to be done. We don't have to do partial fractions anymore because I no longer have a function over a function. The 2 is there by itself, so I just do my ln. So it kind of makes this one kind of worked out to be kind of nice on purpose. So what's the integral of x squared? Right. So 1/3 x to the third. Huh? I haven't gotten there yet. Oh, we missed it. That's okay. What's the derivative or the integral of x? Yeah, so 1/2 x squared. Integral of 2x. Remember, that's the derivative. And now what's the integral of 2 over x minus 1? Right. 2 ln x minus 1 plus c. Okay, I'm not going to throw anything else new at you. Or old. Well, let me rephrase. I'm not going to throw anything old at you. You've now seen everything you're possibly going to have to do to these. Now it's just the problem become a little more complicated. All right. Case 2. So what happens if we have multiples? So what if I have x squared or x minus 1 to the third? If I did this factoring out, it would be x times x minus 1 times x minus 1 times x minus 1. The problem is if I put those in, all those x minus 1s, if I made these three all over x minus 1. All those fractions are basically the exact same. I could just do c plus d plus e over x minus 1. And I lose my exponent. Okay? So we have to have some way to be able to do this to keep that exponent. And how it's done is you literally write it as many times as you need to. So since I have x squared, I have an x1 and I have an x squared. Since I have x minus 1 to the third, I have x minus 1, x minus 1 squared, x minus 1 to the third. No, we're not going to do this problem up. Don't worry.
Why do we need an x again?
Huh?
Why do we need an x?
Because if I left them as, if I just did the x squared, you lose information. So you need to have each term in there.
Wait, for the stuff on the top, what's the original equation?
There wasn't this one? There wasn't an original equation for it. This up here?
Yeah.
That's just the setup of it. That's just make sure you write each one out all the way. There was no actual original equation. But
So why is there like subscript to A?
because it's instead of them using A, B, C, D because it can go on forever, it was answer subscript 1, answer subscript 2, answer subscript 3, all the way to.
Okay. And
That's why I wrote an example down the bottom. This is in essence what it's doing. And don't ask me to show you why, because we'll be here a lot longer and I'll confuse the rest of the class that kind of understood what I'm doing already. The other half of the class wouldn't, like, we'll literally tune it out anyway. I think the book actually has it done out. Maybe not, actually. No, they actually didn't do it out. There might be a book that has it done out. This book does not. All right. Let's look at this one. No, yes, it's fine. Go ahead. There you go. Yeah, just write the example. All right. Is the bottom lower than the top? The top is bigger than the bottom. So we have to do what? We have to do long division. So do long division for this one. And I'm going to cheat. There's your long division. All right. Any questions with the long division? Okay. So we're to this point. So next step is to do what? We have to factor this bottom. So the nice thing is it's 4 pieces, so we can kind of like, let's see if we can pull stuff out of either side first. So I can pull out an x squared out of this side, and I'm left with x minus 1. And I can pull out a negative 1 out of this one, and I'm left with x minus 1. So I have x squared minus 1, x minus 1. Then x squared minus 1 is the difference of 2 squares, so it's x minus 1, x plus 1, and x minus 1. So this problem becomes x plus 1 plus 4x over x plus 1, x minus 1 squared. Any questions how I got that? Okay, so now at this point, we're ready to do our integration by parts. Yes. We could. Kinda.
Yes.
Okay. All right, so we're not going to worry about the x plus 1 for right now. We're literally just looking at this part. Okay, because the x plus 1 we can deal with. That's just an integral piece. This is the part we have to actually split up. So I have a over x plus 1, b over x minus 1, and c over x minus 1 squared. So I have, what are the numbers I'm going to set x equal to? So actually, hold on, let me do one step before that part. So 4x equals a times x minus 1 squared plus b times x plus 1 plus c times x plus 1. So that's what I got. Yes. Oh, actually, I did screw up. I missed the b. I forgot the x minus 1 there. There. So what's missing from here? That's here. Is the x minus 1 squared.
Oh, gotcha. All
What's missing from here is the x plus 1 and 1 x minus 1. What's missing from here is just the x plus 1. Yes.
Why does B only get one x minus 1 and not x minus 1 squared?
Because I already have an x minus 1. So it's like, it'd be like if I had if I had 1/4 and 1/8. I wouldn't have to just multiply the 8 times the 4. I could just multiply the 4 by 2. Right? That's in essence what we're doing here. So I could have x minus 1 squared here, and I would have to put another x minus 1 here because then I'd have 3 of them. But it doesn't really help me.
So if B was like x minus 2, you would still need the square.
Yes. Yeah, because it's not the same thing. So that's why I said this time when I was looking at it, I wasn't necessarily looking at these pieces. I was looking at what was missing from my original problem. Because that's my common denominator. So what do I got to multiply each of those parts by to get that common denominator? All right. So x is going to be what? All right. So let's make x 1. And that means we've got 4. The a is gone. The b is gone. So c equals 2. All right. Let's make, what are we going to make x now? Okay, so -1. So that gives me -4 equals a times 4. That's gone, that's gone. So a is -1. Okay. I don't have any other numbers I can set x equal to. That was going to get rid of something. So let's use 0. Just pick a number. We already have A and C, right? So if I have an A or C left over, I can just plug in what A and C is to find the B. So let's use 0. So this side's 0. And that means I have A times 1 plus B times -1 plus C times 1. And I already know what A is and C is. So let's change those. So A was -1 and C was 2. So I have -1 minus B plus 2. So B equals 1. You could have technically used any number you wanted, except for 1 and -1. I use 0 because it's nice. But you could use 2, 5, 10. Doesn't matter. You still have gotten B is 1. All right. Any questions on the parts part?
So the reason B is like that's because it's taking one of them. It's counting like one of them being out.
What do you mean?
Why B is sorry.
When I'm looking to find when I found B?
Yeah.
Because I didn't have any. So in the past problems that we did, so if you look at
Yes.
if I look at this one, I had 3 parts. So I was able to choose 3 different numbers and get rid of things. In this problem, I only have 2 parts. So I can only pick 2 numbers that are going to make me 0. So I did both those. I found a couple of the letters. So I still need to find B. So I'm going to plug in what I know and pick another number for X. Because I already knew what A and C was, so I could use those. And then I just got to make X something other than 1 or -1, because I already did those. So I just picked a number. You could have picked any number you wanted. I chose 0 because I like zeros, because zeros make things simpler. But you could have picked 1/2 if you really wanted to. And it would have given you the exact same answer. Okay? So this is one of the differences between doing this method as compared to systems of equations. If I did systems of equations, it would have made total sense. We would have just done the process out for systems of equations and got our answer. Okay? That just makes you have to remember how to do systems of equations with elimination with more than 2 variables, which is not necessarily the easiest thing in the world to do. This way, you have to do a little bit of guessing and checking, because you have to pick numbers. Like they don't give you the numbers to choose. You have to pick numbers that are going to work. But I think the math's a little easier this way. And for the most part, it always works. It's like you can, even if there was multiple ones here, you could have picked another number to find things to break it down. Or you'd have gotten a couple things that you could have done a system of equation on pretty simply at that point to find what's left over. All right, so we have so my integral. So I have x plus 1 plus, what was A? A was -1. So -1 over x plus 1. B was 1. That's right. C was 2. X minus 1. And C was 2. X minus 1 squared dx. Excuse me. Yes.
How did you get B as X one?
B is 1. Oh, B is X minus 1?
Yeah.
I made that the first one. And then this rule says I have to do, if it's squared, I have to start off with 1 and go up. So if you look here, see how like I had X squared, so I have an X and an X squared. I have X minus 1/3, so I have that one, then the squared, then the third one. Okay, now we have to do our integral. What's the integral of X?
Right, X squared over.
Squared plus 2. What's the integral of 1? What's the integral of negative 1 over X plus 1? 1. What's the integral of 1 over X minus 1? What's the integral of 2 over X minus 1 squared? No, you don't. No.
Okay.
U substitution. Yeah. So if I make U X minus 1, du is just dx, right? There's nothing there. So this now becomes 2 over U squared, which is what? So I have to add or subtract or add 1. So it's negative 2 in essence. So add 1 is going to become negative 1 and bring it over. So it becomes negative 2 over U. Nope. It's just negative 2 over X minus 1. No natural log at all. The reason why we have to do natural logs of these is if I did 1 over U, that's U to the negative first power, right? If you add 1 to negative 1, what do you get? Nothing. It's gone. That's why the natural log is there. If I had 2 over negative 2, or 2 to the U to the negative second power, add 1 to negative 2, I get negative 1. My U's still there. Okay? It's U to the negative first power, which is why it just goes back down the bottom. Yeah, okay. So that's, you don't have a natural log in this one because we didn't get rid of the U to begin with. Yes.
Can you rewrite the U with
Yeah, I can. I thought of that afterwards. So U is X minus 1. So du is dx. So then I'm doing the integral of 2u to the negative second power, which is negative 2 over u.
let's say 2U to the negative.
Yes.
Please put that on.
Yeah, moving it up top. So this way, because you're adding 1. If it's on the bottom, you in essence are subtracting 1, which is going to be confusing if you try to think of that through your head. All right. Huh?
I'm just cursing.
I did warn you that there was going to be a lot more algebra in this one. Unfortunately. All right. Yes, I could technically put them together. I'm not. No. No. And honestly, it doesn't really help much. Like, you're gonna multiply them, and it's just gonna. It's like it doesn't really help drastically much more. But yes, you could use log rules to put things together to make it a little cleaner. Amazingly, the book doesn't do that. This book has actually it does do this one and this one. But yeah, you don't really have to. All right. Every problem we've done so far. I got one more problem to go. I swear. One more and we're done. Every problem we've done so far has been a linear term on the bottom, correct? If I'm factoring, might not get always linear terms on the bottom. You can run into situations where you have like x squared plus 1, and there's just nothing else you can do. Or like in the first problem when I screwed up and I did put a 2 in the middle instead of a 3, and you couldn't factor it past that quadratic. So there are situations that that's going to come up. So what do? We still have to be able to break it down. Well, what comes out to me is we actually break it down in terms of a linear term on top. We now have bx plus c for my quadratic terms, or bx plus e for the quadratic term. In essence, you want your numerator to always be 1 less than your denominator. Okay, so if I had a cubic, I'd have bx squared plus cx plus d. We're not going that far at all. But the process continues. So if you have a squared on the bottom, you need to have an x on the number. Now, that does run into the situation that we could have. So when I have a linear term, I'm going to do my ln's. Those work out really well. If I have a linear term raised to a power, we just did that. You just use substitution. We can run into a situation, though, where I have a 1 over a quadratic term that I can't do anything with. Now, note there's a big difference between this and what we did on Tuesday. These are not in a square root. And if they were in a square root, we go back to what we did on Tuesday when you have to do the trig substitution. These are not in the square root. So this is the rule for it. I'm not proving it today. This is the rule. So all it is it's x squared plus a squared. So for example, let's look at this one. It's x squared plus 4. So a is 2. Okay, because 2 squared would be 4. So it would be 1/2 tangent negative the arctangent of x over 2 plus c. That would be what's replaced for that integral. Okay. So it's always 1 over a, the arctangent of x over a. If I have a quadratic with nothing on top, or just a single number on top. If I have a 2 on top, that's fine. It would be just 2 over a instead. All right. Everybody got this case down? Okay. One more problem. Just using this case so you can see how it works. Because there's a couple things towards the end that change a little bit because of the top. All right. No long division in this one. We don't have to do the long division. The bottom is bigger than the top, so we don't have to do that part. So step 1 is to do what? Factor the bottom in this case, or cry, one of the two. Yeah. Factor while crying. Typical math class. Difference between you crying now and you crying in high school is you're paying for this. So just think you're paying for this torture. Yeah. All right. So we got this factored out. Okay. So we're going to set up our problem. So this integral, it's going to be a over x and bx plus c over x squared plus 4.
Is there a difference, like you wrote on the fractions bx plus c, instead of writing just b plus c? Or is it just more of like a notation thing?
With, wait, you need the bx plus c here. The x is actually very important here because this is this case where you have a quadratic in the bottom. That's why I'm not just writing b plus c.
Okay.
So the x actually, you want that because you need a linear term over a quadratic. You have to have the top be one less than the denominator. All right. So let's set up our problem and see what we got. So we have 2x squared minus x plus 4 equals a times x squared plus 4 plus bx plus c times x. So now in this one, what I have here, what's the only number that I actually could use? I can't use -4 because -4 squared would give me 16, and that's not going to cancel that to be 0. The only one I could possibly use would be 0. So let's do 0. Because honestly, after that point, I'm going to kind of be stuck. So actually, I'm not going to use 0. We could do 0, but we're still going to have to find b and c anyway the other way. So I'm not going to go through the whole system of equations one. This one we actually don't necessarily have to because of the way it's up. Let's FOIL this all out. Let's actually clean this up and see what I have. And maybe we can match things up to make my life a little bit easier. So this is going to be ax squared plus 4a plus bx squared plus cx. So I have a plus b x squared plus cx plus 4a. And that equals 2x squared minus x plus 4. So based on what I have right there, is there any letters that I can kind of figure out right now? 4a has got to be 4, right?
Yeah.
So that means a has got to be what?
1.
A has got to be 1. So a has to equal 1. Okay. What about c? Well, c has got to be, it's negative x over there and it's plus cx here, right? So c's got to be negative 1. All right. And a plus b is 2. And we know a is 1. So b has to be, b also has to be 1. So sometimes we can just multiply it out and look, and it works out really nicely. Not always, but in this case it did. If you would have done the 0, you'd have gotten what A was. You'd have gotten A is 4. I mean, A is 1. And then you still would have been stuck trying to find B and C, so you still would have had to do this out to do it, because any other ones would have caused you more trouble than was worth to find. Unless you want to deal with imaginary numbers now. I don't think anybody really wants to right now. All right. So we now have our interval. Nicely broken down. We have 1 over x plus, was it -1? No, it was 1. So it was x minus 1. X minus 1 over x squared plus 4. This, if I have addition and subtraction on top of a fraction, what can I do with it? I can split it up. I can't split it up if I have addition and subtraction on the bottom, but I can if it's on top. So I'm going to rewrite this as 1 over x plus x over x squared plus 4 minus 1 over x squared plus 4. Now, let's see if we can find the integral of them. What's the integral of 1 over x? ln of x. What's the integral of x over x squared plus 4? No. This one, we actually have to do a substitute. Actually, it might end up being that. It might. Just give me a second to do your substitution because I didn't do it that quickly in my head. But you have to do substitution on this one. We did this one?
We did yeah. 2 more back.
We did that. No. Not exactly the same. All right, so if I set u to be x squared plus 4, so du is 2x dx, right? So if I pull the 1/2 over, that's there. It actually might be the ln in that case. So I'm going to end up with 1/2 over u, which is 1/2 ln of x. So 1/2 ln of x squared plus 4. So it was that. Sorry, I just didn't do it that quickly in my head.
And I was wrong because I thought it was the same thing for the last.
It does end up working that way out. It just, because of the x, you have to do your substitution for it. All right, so I have plus 1/2 ln of x squared plus 4. And now this right here is my tangent thing that I had in the last screen. So it's minus 1 over 2, because that there, arctangent of x over 2 plus c. This piece right here becomes that. That's that rule. That rule. Because I have a number, I just have a 1 over a quadratic. So I can't do ln, I can't do your substitution because I don't have the x to cancel out. So in this one, I could do your substitution because I had the x there, so I can cancel that part out. This one, I don't have that X there, so that's why that rule exists.
Or whoever can figure that out.
Yeah. Somebody went through and proved all that out.
But just something like we'll eventually notice and be like, oh, like remember this, or is there like a trick?
So-
just recognizing, oh, it's that tan.
All right, so actually, 7.5 is going to be your best friend right now. Because 7.5 actually is all the rules telling you the order to do them in. Okay, so this one right here, it's like this is the one of those ones where we have something here we can't do. So when you get to a point where you're stuck and you can't use something, you got to figure out some way to do it. All right, so like this, we know how to do. This one right here, the first thing you always want to try is do substitution, right? We've tried it. Oh, wait, we can do that. We got it. Good. This one, wait, that's the same as that one, but it doesn't have the X, which I know I need. So I'm stuck. Go look for something that's unsticky. And in this case, because it's not a square root, if it was a square root, we could do the trig substitution problem. But since it's not a square root, we got a rule, and that's what the rule is. So that's a rule I would have on your index card.
I actually remember doing problems similar to this with a weird way of. The first way I learned trig substitution is you like build the triangles and all of that stuff first.
Yeah, you could do it that way too.
So, yeah, that was.
So and that's really what 7.5 does. Is says here's all the rules you've learned. Do this, try this first. If this doesn't work, try this. If this doesn't work, try this. If this doesn't work, try this. It's like, and the more you do them, the better you're going to go, oh, okay, this one I got to use integration by parts. Oh, this one I got to do partial fractions. This one, oh, I can just do substitution. Oh, this one I just know the rule for. It's like you start looking at those things. I will have the practice test up there tonight. I will have it all up there when I get home. So this way, if you want to, so it'd probably be by about 8 o'clock because I don't get home till about 7:30. So about 8, just after 8, it should be up there if you want to download it. It'll be a PDF, so you could easily look at it. There is. Hold on. I'm trying to remember how many of chapter 6 I put in there. I'm opening it. Hold on. So there is 3 from chapter 6 and 7 from chapter 7. So I will post. It should be up there tonight. I'm gonna try to do it when I get home. So yeah, the review test. And if you want more practice, do section 7.5. All right, because 7.5 is all mixed. Like they took all the problems from 7.1, 2, 3, 4 and mixed them up. And that's kind of what your test is going to be like, where they're going to be mixed up. So if you want more practice, 7.5 is going to be your friend for more practice. Huh? Yeah, you can email me, bug me all weekend. I think my game night just got canceled for Friday or for Saturday because somebody got exposed to COVID today. It's like you too. It's like we've had one planned in December, somebody got COVID. We had one planned in January, somebody was. It's like every month.
It's like COVID knows when.
Yeah, we're gonna have game night. It is, but it's like with some people, like it's you still don't want necessarily. If you have the flu, you don't want to be around somebody either. It's just seems to be more prevalent than the flu. What's up?
This one okay? Article on.
Yeah, that's fine.
Yeah, see?
And just get the 188 one.
Yeah. So you,
Yeah, that's the 9. That's the one I've been using.
Okay.
And I can send you the solution guide for that one.
Okay, perfect.
Yeah. When are you leaving?
I won't be able to send the
Okay. So you'll be able to do the test next week,
Yes.
Nice guy.
and then you're going. Okay. All right. That's fine.
Yeah, I'm learning more from that chemistry guy,